In problem number 2, we want to determine A, knowing some information. We know that A times the vector 2, 0 results in this vector, and A times the vector 1, 1 results in this vector, and we want to determine what the matrix A is. Now, we know that this matrix multiplication corresponds to, or this matrix A corresponds to a linear transformation. We also know that the columns of A are the results of evaluating that linear transformation at unit basis vectors. So what I need to do is I need to figure out how the corresponding linear transformation transforms the first unit basis vector and the second unit basis vector. In other words, I need to figure out what A times the vector 1, 0 is, and I also need to determine what A times the vector 0, 1 is. Then they would give me the columns of our matrix A. Well, first of all, what is A times the vector 1, 0? Well, notice that 2, 0, that vector, is 2 times e sub 0. And because we're dealing with a linear transformation, A times 1, 0 is related to A times 2, 0. In other words, because it's a linear transformation, the A times 2, 0 is twice A times 1, 0. Since we know this is the result of A times 2, 0, to find A times the first unit basis vector, we take this result and half it. And so it's going to be the vector, which is 1/2 times the vector with components 2, 4, -2. And scalar multiplication means the resulting vector will have components 1, 2, -1. So we know the first column of A. What about the second column? What else do we know? We know A times 1, 1. We want to figure out what A times 0, 1 is. Well, we know that the vector 1, 1 can be written as 1 times the first unit basis vector plus 1 times the second unit basis vector. And again, since this matrix multiplication describes a linear transformation, that means that A times the vector 1, 1 is equal to A times the first unit basis vector plus A times the second unit basis vector. Even more importantly is we could have written the second unit basis vector as the vector 1, 1 minus the first unit basis vector, which means A times E1 is equal to A times 1, 1 minus A times E sub 0. Okay, what do we know? That means that A times the vector 0, 1 is A times the vector 1, 1, which was 0, 2, 0, minus A times the first unit basis vector, which we just figured out was the vector 1, 2, -1. Okay? That means using matrix subtraction, vector subtraction, the resulting vector has components -1, 0, +1. So now we can determine matrix A. Its first column will be 1, 2, -1, and the second column will be -1, 0, 1. We're done. And it's all based on the fact that matrix multiplication is related to linear transformations.